So here's the context, and then in a second, you guys are going to get into groups and kind of get the data for the simulation that we're going to do. All right, so last year, East Kentwood High School had 30 students take the AP Statistics exam. They were informed later that the College Board gave 2 forms of the exam, which were randomly assigned to the students. And here's the result. So those students that were given Form A, there were 15 of them, here were their scores. Pretty good scores, right? So here was Form B, and here were those scores. 15 students got Form A, 15 students got Form B. So I'm sure these students, like you guys, if this happened to you guys, you would be sitting there and you'd be like, wait a second, these 2 forms should be the same, right? College Board is supposed to make sure all these forms are pretty much the same, but those people that got Form A scored better than Form B. So our thought is, well, are these actually similar in difficulty? Do they have the same difficulty, or is Form A maybe a little bit easier than Form B? Okay, so let's back up just a little bit, and we've discussed this before, but let's talk about it again. What are the only 2 possible reasons why we would get something different from 0, right? We would expect to get 0. We expect that they're the same, but we didn't, okay? So what's one possible reason why we would get a difference other than 0? It happened just by chance. So what's actually true then? What's one possibility for what's actually true? They actually are the same. It just so happened that we got a difference of 0.2 by chance, okay? So out here to the side, I know you don't have a whole lot of room. Let's go ahead and write that first possible reason as to why we got something other than 0. So the tests, let's use words for right now. The tests are similar or are the same. We just got 0.2 by chance. Okay? And we know that that's possible because even if they really are the same, from sample to sample, that difference will vary. So in the long run, it should be 0, but from sample to sample, it could be both above or below 0. All right, what's the other possible reason? The tests actually are different. Okay, so let's write that down. For possibility number 2, the tests actually are different. And different as in difficulty, right? Right? And these are the only 2 explanations as to why we would get something other than 0. Okay? And so when we do a test, a significance test, or we do a simulation like we're going to do, what we're trying to figure out is, or what we're trying to gather is evidence to show that 2 is actually the correct reason. All right? The whole reason for conducting a test is because we think that they're not the same. All right? If we thought they were, we would just go about our lives, right? But we think option 2 is pretty much what is true. And so what we need to do is we have to rule out option 1 as a possible explanation. Okay? If we can essentially rule this explanation out, the only explanation left is this one. And so we're going to go through a simulation just to figure out how likely is it that option 1 is the real explanation. Okay? And so what we're going to see is how likely am I to get a value of 0.2 just by chance? Okay? If the tests really are the same. So the first thing we're going to do, if you kind of go down to the next part of the task, is we're going to assume that the 2 forms are the same difficulty. Okay? So assume they're actually the same. And so if they are the same, somebody that scored a 5, like our friend Doug here, okay, he would have gotten a 5 no matter what form he got. If somebody scored a 3, since they're both the same, or that's what we're assuming, they would have gotten a 3 no matter which form they got. So we can take these 30 scores and we can randomly assign them to Form A or Form B, and it doesn't matter. Okay? Because a 3 is a 3, or a 4 is a 4, no matter what form they got. Does that make sense? So we're basically going to take these 30 scores and redistribute them to one of those 2 forms. And then we're going to recalculate this for our particular randomization that we do. All right, let's take a look at the dot plot that you just sketched. And again, I know it's not perfect, but I do want you to add a couple of things to it. first thing, if we look at question number 3, we're going to add something to it that comes from this question. So let's look at that together. East Kentwood, if you remember from the beginning of the problem, had a difference of mean scores of 0.2, all right, which means they were higher on test A, form A. Is this outcome surprising if we assume both forms are the same difficulty? Well, what is it that's going to tell us whether or not that it's surprising? Like, what am I looking for? What do you mean by p-value?
Like, what is the chance of you getting that if it is all equal?
Okay, so what's the chance of it happening? So we're looking for a probability, right? So if they are the same, and keep in mind that this whole simulation was done under the assumption that they're the same. That's why we could just randomly assign them to either of the two forms, right? Then how likely, probability, is it that we would get a difference like East Kentwood got? Now let's actually add a little something to this. So 0.2 is what we're looking for, but what would actually give us even more evidence that the tests are actually different rather than just 0.2? Really, what we want to look for is not just how likely it is that we got 0.2 by chance, but how likely would it be that I would get 0.2 or something even further away from what it should be, right? It should be 0. So on your dot plot, I want you to add in where East Kentwood's difference lives. Okay, and so that's right here at positive 0.2. Okay, so maybe under here I'm going to write EK for East Kentwood. Let's say EK results, and let's draw a little arrow right here at the 0.2. Okay, so right here is their sample difference that they got. Okay, and so there are a couple of 0.2s that you guys got. Okay, those would give evidence that the tests are not different or are different. And then everything to the right. So I want you to draw a little vertical line. We're going to kind of separate all the sample differences just like East Kentwood got, or something even more extreme, from the ones that were not. Okay, so let's draw a little vertical line right here just to the left of those 0.2s. Okay. So if we want to find how likely or how surprising it is, all right, a probability, what am I actually doing with this dot plot? How would I find the probability of getting 0.2 or more just by chance? Okay, which category are we talking about? Yeah, so we're looking at everything that lives to the right of that particular line. Okay, so we want to count how many times did I get a sample difference of 0.2 or something even more. Okay, so out of our 22 trials, how many times did it happen that we got something at 0.2 or higher? 7. So we have 7 times it happened. Okay.